Let's look at this is review worksheet number 4 over chapter 7.1 and 7.2, working with area and then also adapting area to find volume of rotated objects. So number 1, we have a graph showing the negative x squared plus 4x plus 5. That's this parabola here. And the line y equals x plus 1. First thing we can do is we can find our boundaries by setting our equations equal to each other. Bring everything over to one side. We factor, we get 4 and negative 1. And now we can plug in the area formula is just identifying that, connecting that distance between the curve, the boundaries of our two curves. And then we see it's the top minus bottom. So we can start with the top. The top of the radius is sitting on the parabola, so the negative x squared plus 4x plus 5 comes first. That's the top. Minus the bottom function, so the bottom of the radius is sitting on the line, the y equals x plus 1. Distribute the negative through, combine like terms, and now we can get it ready for power rule. Evaluate using our upper and lower bounds, and we get 20.833. No pi involved, no rotation here, so just 20.833 square units. All right, number 2, we have a shaded region that is created by the parabola that opens down and the line y equals negative 8. So first things first, let's find the intersection. We set the negative 8 equal to the negative x squared plus 7x to look for these points there. We bring everything over to one side. We factor, we get negative 1 and 8. And now we do we draw our dotted line. Our axis of revolution is up against the flat surface of our shaded region. So all we need to do is one radius that connects from the axis all the way to the furthest boundary. So we just do top minus bottom, the negative x squared plus 7x minus a negative 8. And now we have our volume formula, pi big radius squared from negative 1 to 8. Plug in the calculator, leave pi out of our calculator, and then we just add that in ourselves. Okay, 1968.3 pi cubic units. All right, number 3, same shader region, but now our axis of revolution is, there's a gap now. So because of that gap, we know this has to be washer method. Our bounds remain still negative 1 and 8 from before by setting the equations equal. And now we do top minus bottom. We extend our two radius, that one that extends from the dotted line all the way to the furthest boundary. That's going to be the longer one, the big radius. And small radius extends from the axis to the closer boundary. And now we just pick out the top of the radius and the bottom of the radius and subtract those two, and that will give us a representative length of that segment. So the top of the big radius is at the negative x squared plus 7x. The bottom is at the negative 10. So we have top minus bottom. The two negatives become positive. And now we do top minus bottom. The top is at the negative 8. The bottom is at the negative 10. We get positive 2. And now we can use our washer method formula. Pi integral from negative 1 to 8. Big radius quantity squared minus little radius quantity squared dx. Use our calculator to do the rest of the work for us. We get 2454.3, and then we add pi in ourselves, not in the calculator. Okay, number 4. We have the shaded region that's created by the negative x squared plus 2x and the line y equals negative 1. We find the boundaries by setting the equations equal to each other. Bring everything over to one side. We factor, we get 3 and negative 1. Our axis of revolution is all the way up at y equals 5. So we see there's an obvious gap. We need two radius, one that extends from the axis all the way to the furthest boundary. Notice that we don't do anything with the x or y axis. These are just part inside our graph, but it's no longer a boundary that we're going to be using. Okay? It's not the boundary of our shaded region. And then little radius extends from the axis to the parabola. So big radius, 5 minus negative 1, top minus bottom. Little radius, top minus bottom, 5 minus parentheses, negative x squared plus 2x plus 2. Distribute the negative through, combine like terms, and now we have our volume formula, pi, integral from 1 to 3, big radius squared minus little radius squared. Enter in our calculator, leave the pi out of our answer. We get 1408 over 15, and then attach that pi, cubic units. All right, number 5, we have shaded region that's created by the y equals square root of x, y equals negative 2. I meant to also say x equals 0, so x equals 0 is also a boundary here. And y equals negative 2 and x equals 5. So we have our shaded region. We're rotating this shaded region around the line y equals negative 2, and we see y equals negative 2 relative to the shaded region. There's no gap. It's right up against that side, that bottom side of our shaded region. So all we need is one radius that extends from the axis to the boundary of our shaded region. Okay. Our bounds are easy to find. We can tell by looking at the graph. The left bound is 0. The right bound is going to be a positive 5. And then all we need to do is find radius. So top minus bottom, root x minus a negative 2. 2 negatives becomes a positive. So then we have pi, big radius squared from 0 to 5. Expand, use power rule, or enter in our calculator. And we get 62.314 pi cubic units.